go to hands-on gradient boosting with XGBoost and scikit-learn, the GitHub page. Okay, click on it again, and let's go into chapter 1 and pull up this bike rentals clean.csv file. Let's go ahead and click on that. Click view raw, copy it in, open up a new Colab notebook. There's going to be a big topic. Let's put in the URL and import pandas as PD. df equals pd.read underscore CSV. And let's go ahead and pull up this data. And what this is going to be called is going to be cool. We're going to convert regression to classification. Okay, I forgot something. I like showing you guys the live errors. It says, sometimes read it, CSV missing one required positional argument. So yeah, I didn't put anything in there. You want to put the URL in there. It's got to read something. Okay, so in this data set, look at this, count as number of bike rentals, okay? It varies. Okay, this is not classification, this is regression. Now, you can convert any regression data set to classification. All you have to do is figure out where you're going to cut it off. Before we do that, let's establish that X would be everything in this data frame. It's cleaned, starting with all rows, and columns starting with 0, go all the way up to and excluding the last. And Y is going to be the last one, which is just, we can do it by name, count. So far, right? But we're going to change it. Okay, so I want to reestablish my X and Y here. And what we're going to do now is we're going to make a new column of data based on this count. We're going to split the count into zeros and ones. Any regression data set, you can do this, right? Regression means you have a range of values. It's not classification. But you just got to find, well, where do you want to split it? Well, how do we figure this out? Well, look at the values of your column, right? So if I look at sort of the descriptive statistics, okay, of that column, my Y column, we can see now the median is 4,548, and the mean is 4,504. So if I want to cut this data in half, and you may have other reasons for giving different numbers. I think using that halfway point is a great one because then it's going to be balanced as well. We can say, are there a high number of bike rentals or aren't there? Okay, and this could be practical for a company. A company might say, you know what? If there's more than 5,000, we need an extra employee. Otherwise, we don't, per store or something like this. Okay, so let's learn how to do Python code with pandas to split this data set based on, let's just use 4,500 to keep it balanced. Okay, so what we do, we're going to define a function, right? And we're going to call this function something based on what we're doing. So this is bike rentals, and maybe we'll give it an underscore, like where are we going to cut it off at? 4,500. And we're going to do this for every row of data, okay? Now, what we do if, and we're looking at the row, sort of the count, right? If this is greater than 4,500, okay, then what do? We're simply going to give it a value of 1. Else, all other cases, we just give it a value of 0, okay? And then what we're going to return is the value. Okay, so we're going to apply this to each row. Okay, here's the function. Now, how do we apply it to each row? Well, we create a new column, and maybe this is, I don't know, you got to call it something like count, I don't know, 4,500. Because that way I'm preserving information as to what it's actually doing. And what we do now, it's df.apply. What we apply is our function, which we named rentals 4,500. And to do it to the columns, rows 0, columns 1, its axis equals 1. And then let's run this code, okay? So just to recap, we define a function, okay? And the function is designed to work, you're doing it one row at a time, and so you're just looking in each row. Hey, I set some criteria. If it meets that criteria, let's give it a 1. Otherwise, we give it a 0, and I return the 0 or the 1, okay? And then we name the new column, okay? And then we use df.apply to sort of apply this function. And I think we do need to specify a column axis here. Okay, so let's run the code. And then now let's check df, of course, because we want to see, okay, and these are zeros, which are correct because the early rentals are not good. Let's check the later rentals. Oh no, there are zeros too. I think that's probably okay. Let's do, how about this, a random sample? Remember this? Sample, here's a random sample of 10 rows, df.sample. And so now you see a mixture of zeros and ones. Okay, so what we did is and you can see also that they're matching appropriately. What we did is we've converted this count column to this count 4500. Now, what we're going to do is now we can apply logistic regression, but instead of y being the count, okay, we change now y is df, and it's this c and t 4500. Okay, I've already established what x is. And the whole point here, okay, this is critical to understand. By making this change, which you can do on any regression data set, we now have a classifier. We need a classifier. And logistic regression serves that purpose. So let's code it up. Set the model equals, oh, we need to import it first. From sklearn.linear model. Here we go. It's going too fast for Colab. Import logistic regression. There it is. Then we're going to initialize the model. Model equals what? Well, what do we import? That's what we're using. Logistic regression, note that it's one word. Now we fit it to x and y. And then we're going to go ahead and score it. See how it does. And then we remember that max iter often causes errors. Now this data set is much smaller than the other ones. Let's go with, I'm going to go with 5,000 again. I think it'll be fast. Okay, so go ahead and run the code and look at that. We get 87%. Great. So I'm going to pause there, but let me just give you some advice. If you, and we're going to look at other regression models, okay? Linear regression is not like a strong machine learning model. We're going to look at strong regressors. But you should try classification, because what you might find is that you can sometimes get way better scores using logistic regression than you can using a standard regressor, okay? And what I mean by that when I say standard regressor, we will be sort of kind of fleshing out the ins and outs of what's a regressor and what's a classifier and what are the different models that we can use. But if you're not getting good scores and you need regression, you should try classification. It's worth trying anyways, 87% correct is actually, right, very good. And in practice, I'll also close with this. It's not really about just getting the best score. Okay, right? Because you could always kind of tweak this to sort of force higher scores. That's not the point. The point is to have something meaningful, and what's meaningful here? Maybe the goal is to predict the total number of bike rentals, but it could be, it's a sensible sort of solution to a problem like how many bike rentals do we have, a lot or not a lot, because that can help somebody with the staffing. So, this is a legitimate, I think, logistic regression problem, and I think you'll often find that they are. You can classify your data in a lot of different ways using the code provided here.